My lightning talk is about Raft, which is a consensus protocol. And the brief of it is that how do you get two computers connected via a network to agree on something, right? Because there is obviously, it's a pretty tricky topic, but the basic idea is you need some way for two computers that are cooperating to agree on something. Now, this something can be an ordering of events, it can be a set of tasks or a set of accounts or something like that, right? So take, for example, your bank, right? So if there are two people who are making a transaction on the same account at the same time, or let's say two people who are withdrawing money from one account at the same time, how do you know if the account has been overcharged, right? So you need to have some synchronization between these two computers to ensure that you don't get something wrong, right? So it is possible to overcharge the account if you don't do your coordination correctly. So a consensus algorithm basically steps in and says, okay, I'm going to decide what the ordering of events is, and I'm going to decide if something is correct or not. So obviously, this is very, I'm watering it down extremely, but the basic idea is there are nodes that talk to each other on a network, and they need a protocol to decide on how to agree on something, right? An important distinction is we are talking about cooperative systems. So of course, you can say, like whatever protocol you define, you can have some other node come and say, oh, you are wrong, I am correct, right? And by some protocol magic, it tends to work. So those are Byzantine, that's called a Byzantine fault, where you basically have a hostile node in that system. But that's not the situation we're considering. So consider like a 5-node cluster, right? You can't see the pause icon here, but there is a pause icon in this space on my screen. And basically what happens is, this is a brief like animation of the protocol itself. So Devdutt spoke about Paxos before, which used to be the state-of-the-art protocol to do consensus until a bunch of researchers from Stanford said, okay, we can do better. Raft is complicated as hell. Even the folks at Google don't understand it, so there's no point. So they came up with a new protocol with teachability and learnability as a specific goal, and that's Raft, right? So how many of you have used Kubernetes before? Right? So every instance of Kubernetes has Raft running inside it to coordinate between the different nodes that are there. Right? So Kubernetes relies on etcd, which is a key value store, a distributed key value store, that uses Raft under the hood. And there are a lot of distributed systems that use Raft to coordinate. So like Google, some of Google's internal databases use Raft, CockroachDB uses Raft. A lot of systems where you have multiple nodes coordinating on some task use Raft. But this talk is not about the protocol. This talk is about showing that no matter how terrible you can implement it yourself, which is what I've done. There's a paper and there's a whole bunch of educational material around Raft, but you can basically see that, so let me pause the time. So you can see this here, this node is the leader node. So at every specific period of time, the cluster elects a leader, which gets to decide the ordering of everything to make sure that everything is correct by whatever definition of correctness we've got. And then all the data goes through the leader, which decides, okay, this is the right order, this is how it should be, there's nothing going wrong here, and then sends the data to all the other nodes in the cluster. So you have correctness and you have replication, right? The other thing you need is fault tolerance. So what I'm going to do is I'm going to kill the leader, and this simulation is not mine. This simulation is raft.github.io, made by the authors of the protocol. So I'm going to kill this node, right? And I'm going to set time a little slower. And so you can see this node's dead. It's not going to respond to anything. And eventually one of these nodes is going to elect itself the leader. I think it's node 2. So it says, okay, I'm the leader now. And it gets votes from everyone. And it basically assumes the responsibility of the leader, right? So pretty messy protocol, but the paper is fairly accessible in that all the RPCs and everything, all the invariants that you need to check are defined on one page itself. And I have a Rust implementation of Raft. It's pretty terrible, and let's hope the demo works. But I have an implementation here. So I'm going to start the leader node here, and I'm going to start some of the other nodes here. But yeah, basically, so it's recompiling. Oh, something went wrong. Okay, so never mind. Let's skip this. But basically, I have an implementation here where you can see that there's an RPC server that's being spawned to handle these requests. And so this is open source on GitHub here. It's at Anirudh Rowjee /limecachd, and you can run this yourself. But what's there here is basically like a very watered down version of an implementation of this that's in Rust. So if you're interested in Rust, if you're interested in consensus, this is probably a fun thing to check out. You can see that over here, I've defined a bunch of RPCs. And let me just show you. So like the actual code for that is here. And the whole algorithm is decomposed into a bunch of RPCs that are there. Probably not doing a very good job of explaining this right now. But so you can see, right? There is, so append entries is basically what does the replication. And you can see that there are some invariants that we're checking. We're checking to see if terms, which is a logical notion of time that the consensus protocol uses, we're checking to see if there's a violation of that over there. Then we are checking all the entries that are there, like just validating that all the entries are in order. And then we are writing it to our replicated log, and then the algorithm will take care of replicating the rest of it. So my point being, this is not a lot of code, right? And you can see that if I had a working demo at this point, I could have shown you. But it's there on my Twitter. And I basically got this project to a state where I have a node coming up in the cluster. I have proper leader election happening the same way that you saw it in the animation there. And I have data being replicated from the leader to the other nodes. So it's a very like work in progress implementation, and it needs a few refactors. But point being, even things as scary and as complicated as consensus protocols can be something you just hack on, which is what I wanted to show with this thing. So here is the repo. Please feel free to check it out. And I will probably try and find some way to get a demo up. I can probably just try again. Let's see if that works. Okay, node ID 1, 2. Okay, so you can see that the leader node has registered these two nodes as peers. So what's now going to happen is the leader is going to initiate an election here. It says, look at me, I'm the leader now. And you can see that the RPCs have been received by the other two nodes. And it's basically sending out a periodic heartbeat to make sure that all the other nodes in the cluster know that the leader is alive. And you can see that that's happening, right? It's saying sending heartbeat. And now you can see that it's actually started replicating data. So there's key1 and val1 here. And you can see that quorum replication has been confirmed. So write is not confirmed unless a majority of the nodes in the cluster have acknowledged that, okay, I have the data that you're trying to send to me, right? And there's a whole bunch of like terms and indexes and a bunch of other things. So you can see that you now have the next entry, key2 and value2. And you can see that the other peers have committed key1 and value1 to their persistent stores, right? Let's try something a little funky. I'm going to kill the leader node. And let's see what else happens. So you can see that these two nodes have reset their election timers. And one of them is going to win in terms of having won the election. And because these two know about each other, one of them is going to try and initiate an election. And yeah, this is slightly buggy because it didn't receive a response from that. And yeah, so the implementation is not there yet. But point is, like one of these nodes initiated a leader election, and it tried to become the leader of the cluster. So that is the protocol in action, flawed but in action. So yeah, that's all my talk was about. I just want to show that it's not all smoke and mirrors. Like it is just complicated code, but it's still code, and you can do it. So yeah, that's my lightning talk. Thank you folks so much for listening.